Well, do you want to make a start? Do you want to introduce Lachie?
Let's do it, yeah. I'll do a little introduction for Lachie. Lachie is keenly interested in the realisation of great buildings, having worked on commercial, residential, industrial, civic and healthcare projects since graduating from RMIT in 2004. He has amassed a wealth of experience working as lead documenter and specialising in BIM, predominantly within design-led architectural practices around Adelaide and Melbourne. As someone who's both inspired by the big picture and able to turn his eye to the finer details, Lachie has a somewhat rare ability to listen, consult, conceive, and consolidate the technical with the aspirational. Like many other designers, he's inspired by form, light, colour, ergonomics, and aesthetics. But since starting his own business 5 years ago, he's seeking to couple good design with intrinsically sustainable solutions. The journey of running his own company, Harmonic Designs, has allowed him to specialise in topics he's passionate about: energy efficiency, thermal comfort, and carbon neutrality. This ultimately resulted in his collaboration with Melanie Lupins from Sustainability Certified in their award-winning entry for the 2022 True Zero Carbon Challenge. Most recently, in 2023, Lachie has taken on the role as chairperson of the Climate and Sustainability Advisory Committee for Building Design Association of Australia, helping to forge new policies for that national member organisation. So Lachie is going to share his learnings with us about how important it is to design net zero buildings. So welcome, Lachie.
Yeah, exciting stuff.
Thanks, Christine. So this presentation is seeking to demonstrate what a net zero house looks like in particular, but of course that does, the principles translate to any building. We're going to focus on a case study, which is the design entry that we were awarded for, that Melanie mentioned, as part of the True Zero Carbon competition that we did last year. So it was a fantastic opportunity to work with a thermal performance assessor, and that's Melanie Lupis of Sustainability Certified. And we cracked up a great friendship from this process. That competition, True Net Zero competition, was run by Sustainability Victoria and Design Matters National. We've both been really keen to educate others about this process of designing for net zero. First of all, I just want to go back a step and define net zero, because I certainly understood it to be a concept. Now I feel that I know what it really translates to. But as this competition was seeking to do, it is wanting to identify all energy in order to understand what we're going to zero. So net zero refers to the balance between the total amount of greenhouse gas emissions produced and the amount removed or offset from the atmosphere. So when an entity or system achieves net zero, it means the emissions it generates are offset by an equivalent amount of emissions removed from the atmosphere, or by implementing measures that prevent the release of those emissions in the first place. This graph on the right-hand side represents what we tabled in our spreadsheets in terms of the total carbon that the house was estimated to produce as a combination of the whole energy picture, and how that was offset over time via the photovoltaics. So in our case, we're using PV. So you can see that starting in the year 2023, it goes down a little bit each year based on the energy we pay back. So as I've mentioned before, the true definition of net zero has to include the total amount of greenhouse gas emissions. In terms of buildings, there's two primary components which relate to those emissions. Number one is what people generally understand, which is occupational energy, the production of CO2 via energy we consume in our homes, offices, and buildings. Prior focus on energy consumption within the NCC has been associated with heating and cooling. NCC 22, which we all know is unfortunately delayed for adoption, but that requires the evaluation of equipment that we use in our buildings, and particularly in our homes, referring to fixed appliances and whole of home, looking at the broader picture of all energy consumption, not just heating and cooling. Number 2 is what everyone's ought to be talking about so far as I'm concerned, which is embodied energy and the production of CO2 via the energy we consume in construction, in processes like transport, manufacturing, and assembly. If we are to zero all the emissions consumed, then net zero is only achievable by calculating occupational energy and embodied energy. I've made a bit of a footnote about that because obviously this is a complex picture. So, in another 25 years, if we all achieve net zero, or all industries, then we would have less requirement. If we're trying to undertake a project like this, we'd have less requirement to actually calculate the embodied energy, because other industries would have taken care of that energy and we would only be looking at the consumption part. However, that's not the case at the moment. So our design as a case study, the premise is quite simple, but the calculations are anything but, and all of this stuff is very nuanced and very new. Sustainability Victoria got together with Design Matters, who are obviously two groups quite passionate about creating a new focus on the realities of net zero, and hence they got together to create this competition. One of the people on Design Matters, Jeremy Spencer, who's been a long-time advocate in the industry, he put together some fairly hefty spreadsheets to help calculate. And we also had to use a tool via a company called the Footprint Company, I think they are. And so it was really, it was quite a lot of work to go through every item in the house. Talk a bit more about that later. But the idea was to add up all the carbon produced by the home and then determine the payback period required by on-site renewables, in which case we use PV, some of which you can see on the rooftop that's rendered there on the right-hand side. So the aim sounds relatively simple: reduce energy consumed by construction methods to reduce that embodied carbon, reduce the energy consumed by occupants, and then calculate the total energy that will be consumed for each year of the building's occupation, and design a realistic renewable energy system which will put that energy back into the home over a period of time. And it's that period of time, obviously, which is crucial, something I'd like to wrap up on later. So optimizing occupant energy. After creating a bespoke design, which addressed the brief spatially, aesthetically, and with thermal comfort in mind, Harmonic Design worked with Sustainability Certified to achieve design optimization such that we achieved a full 10-star NatHERS rating. So we were quite impressed with our design. And that meant that we moved that Melanie, she was working her, I think it's first rate 5, we had to use that tool, first rate 5, the NatHERS rating. She was really looking at tweaking every position, every window, so we'd get it really optimized in the model without doing anything too crazy, that is. So we achieved good solar passive design with good sun shading, good window placement, airflow, thermal mass, and high amounts of insulation. And that meant that where this was based in Sydney, where our design ended up being based in Sydney, we did test it in Adelaide and Sydney. I'll talk about that later. That helped us to achieve, because it's a little bit more mild climate, that helped us to achieve a full 10-star NatHERS rating. And what we were, estimated to use in energy consumption is just 2 kilowatts per meter squared per year. And that's very minimal. It's certainly on par with Passive House, for example. So just a comment about that. On the left-hand side is the star rating that we achieved in Sydney, as I've mentioned, so 5.8 megajoules per meter squared. And I've put in brackets there the kilowatt hours, because I do think it's important to translate to kilowatts, because that's actually our common form of understanding about electricity usage, for example. And that meant that with our approximately 15 kilowatt solar system, we could pay back that energy by the year 2040. So if we looked at this situation in Adelaide, we actually achieved a faster payback. we achieved a payback a year earlier, even though it was a 9-star rating based on thermal loads. And 9 stars obviously also extremely high, but that meant that we had more expected energy usage, but we could pay it back faster because we have more sun hours in Adelaide. So that's very interesting. And this is one of those things where it's worth doing a study on a house to look at all of the energy, because those two main components in terms of embodied energy and occupant consumption, they change so much. Like you can have a small house, but it might be made of steel, concrete, and glass, and that has some really high embodied energy. So it might have a small consumption, but the embodied energy might outweigh that vastly. We'll talk about that again in a second. So what do we do to optimize thermal comfort? Well, we layered materials quite heavily, but nothing too crazy. We've used conventional design, as you can see in this picture, which we've detailed within the documentation. We use timber framing, we use bat fill insulation, but with our external walls being an example of a robust wall system, we achieved really high R ratings of between as low as R5.3 and up to R5.4. And the example there you can see in this particular example, we used timber, or being WeatherTex in this instance. We had that on a batten cavity. We had a vapor permeable membrane. We had what we've used as a sheathing behind that cladding was a 50mm DuraPanel, which has a high thermal resistance. And then we used R4 glass wool in the walls, and that was achievable by doing a 140mm stud. So that combination works very well. So every component to be constructed within the design was calculated, including landscaping, fit out, and solar PV. What we quickly understood was how significant the percentage of embodied energy was when compared to the occupational energy consumption, particularly when considering what we specified, that we specified relatively carbon-friendly materials. So the only thing in there in this design which was carbon heavy was the concrete. That was the most significant thing. And I don't have the figures right on this screen to discuss. It might be a bit boring to go into the detail, but so in Adelaide, as an example, going back to that local example, we were estimated to be using 21.7 megajoules. I think that's based on, anyway, let's just throw this out there for the minute. Yeah, we were looking at using 21.7 megajoules per meter squared with a total footprint of 3,710 megajoules per annum, or in terms of kilowatt hours, that's 1,206 kilowatt hours for the whole building. This home would contribute in the order of 13.6 tonnes of carbon to the atmosphere per year, whereas the embodied energy represents approximately 190 tonnes. So it would take 14 years of occupation to match the energy used during construction. So this, for me, was a significant learning, understanding just how much energy we're using in construction. And we used materials that, even like the DuraPanel, which is carbon sequestering. Now, admittedly, the computations for that was complex, so we didn't really get any offsetting from using that. That would be a bonus. But there's already so much energy being used in construction anyway, that yeah, it adds up to this significant amount. So that balance, that weighing up of what your building is made of, how big it is, and then whether or not it's efficient, those things, neither one nor the other is the absolute silver bullet for designing for low carbon. It's definitely a combination of both. So just to comment really on carbon accounting, I think there's a growing need for carbon accounting personally. So I think that the quantity surveyors out there should really get their heads around that. There are newer and easier methods coming online. The point of this competition was to highlight the need for understanding the basis for calculating energy consumption and energy payback. But I think understanding energy is very empowering. Here's my little dad joke. When we size solar PV systems, there's generally always going to be an excess amount of energy produced during the daytime. In the case of this case study, the true blue zero CO2, which is what we called it, we proposed a 15 kilowatt system to provide payback within 17 to 18 years. But even a typically sized 6.6 kilowatt system, which is what I'm experienced with in my own house, will produce vastly more power in a year than a household would consume. Certainly in the case of our house, that's the case. We have a smallish house and an reasonably energy efficient house. And yes, it's very interesting when you look at your inverter stats, which I can show you a bit later. So according to LG Solar, the average consumption of a 4-person household in Australia is considered to be 21.5 kilowatts a day. Now, ChatGPT gave me a slightly different variation on that theme, but it's somewhere in the realm of 16 to 20 kilowatt hours. Bringing this back to my own experience, some screenshots of my recent energy consumption at the start of August. So an average north-facing 6.6 kilowatt solar PV on the rooftop in Adelaide is almost 30 kilowatts during a sunny day in winter. Now, this is direct experience recently. This is what I'm getting. You know, one day we produced 29.25 kilowatts, of which we self-consumed just almost 8 kilowatts of that on the 2nd of August. And obviously there's the hours in the morning where we, turn the air conditioner, the heater on, and we're not getting to use that energy. But what this looks like is this is time in which we can store that energy that we're not consuming, quite obviously, because the yellow represents energy that we've used in that time, and the rest of it's just all the abundant energy that's going back to the grid. So for most people, energy being exported back to the grid, retailers are only paying about 3 to 5 cents, something like that, for buying back power, and charging us 10 times that amount to consume it. So it's hard to see why we will. It's hard not to see. It's not hard to see why we will all be buying electric vehicles and home batteries, because we need somewhere to store and reuse that energy, and the economy is telling us that's what we should be doing, or the economics, I should say. So this is really just a bit of a footnote, well, an extension to that concept, I should say. If we take that case study of that model for future living, we can see that a home of this nature can contain a family of 5 within a comfortable, thermally resilient building. On top of that, if we imagine the occupants of this fully electric home as being owners of an electric vehicle, we'd anticipate the following charging capability directly from the home's grid. Based on that 15 kilowatt PV array, a total of 23,325 kilowatts could be produced per year in Adelaide. Maybe more, maybe less. If we take just 50% of that annual PV production, assuming that's all that we can garner for what would normally be exported, that will put just 11,662 kilowatts of free electricity directly from the sun into a car, potentially. If that car were a mid-size EV, like the one we see on the left-hand side, and that consumed an average of 20 kilowatts per 100 kilometres, that car could travel 58,000 kilometres per year from the owner's rooftop solar. That's free energy from the sun. I've thrown in here some links, which should be helpful if you want to come back to this later, but I won't won't go on about those. And I'll just leave it on this screen to say thank you and let you know that I have started a website dedicated to selling this design and some other designs, and that's in its infancy, but I'll leave that on screen whilst we have question time.
Fabulous. That's fantastic. Thanks so much, Lachie. I'm just wondering, Lachie, or what your thoughts are then on with the embodied energy being such a significant component. What are your thoughts about people actually then taking current stock of houses and revamping them rather than building from scratch?
Yeah, look, well, I think it's a good question, and it's something that people ought to understand. I mean, I think if we had a proactive government who really was trying to attack the issue of energy consumption and going net zero, they would be saying, we've all got an energy budget, right? It's like every individual should have an energy budget, and that consumes all energy contains all energy we would consume in our lifetime. And it becomes fairly simple then. I've got this house, am I going to knock it over? Is it full of bricks and mortar that contain a lot of carbon locked up? Really good consideration.
Something to think about. Did you sort of have a feel for the size battery, or how that you're talking about electric vehicles mostly, as far as house batteries go? Did you sort of touch on or have a think about sort of what the size of that or how that might work, or whether what you sort of see happening in the future?
Look, it's a good question. I think my take on batteries is that I can see that they're very valuable for people who, like for large households who have children and using a lot of energy over the night time. In the instance of our family and our experience with solar PV, a battery would not pay off. But the example of the car is one I can relate to directly. We recently bought an EV, and that EV that I was showing you, and so that experience is real for us in understanding what we're pulling out of our PV and where we're putting it. And what I can tell you in relation to that is the bigger the battery, the better. But batteries are expensive. They're also hard to recycle at the moment. So what we do with that battery is, I think we've got to be very careful in how we use that storage methodology. And I think one of the best places is to put it into an EV, because as I said, the potential for that power is not infinite, but is huge. So, you know, on those 2 days that I showed a graph of that, of how much energy we were exporting to the grid and where that was actually going, the reality is you can't see there that energy that was being exported is actually going into our car. And on that day, so over 2 days, we've charged for free half the capacity of the car, because the car is approximately an 80 kilowatt battery. And so we were able to export 20 kilowatts each day into the car for a total of 40 kilowatts over 2 days, meaning we filled up 50% of the car. And given that we do long distances, that's good for us. So yeah, really, that's where the conversation, the energy literacy needs to come into its own, because, sorry, I'm rambling a little bit now, but like I didn't get quite an opportunity to talk about why I think we should be moving away from megajoules and converting everything into kilowatt hours, because all of our equipment is rated, other than gas equipment, for example, but all of our electronic equipment is rated by kilowatt hours or watts and kilowatts. And it's like switching from the imperial system to the metric system. So it would be the most responsible thing for people to do is to only state things, well, to make sure they do state things in kilowatt hours, so that we can understand one for one consumption and storage.
Just another thing to kind of like compound on that, recently in South Australia is I guess it's a SA government and SAPN sort of program, but in collaboration with RAA and Flinders Uni, they're trying the first vehicle to grid, or basically two-way charging and use from vehicles. So it's sort of like watch this space. We're already kind of doing some cool trials, but yeah, it's an interesting kind of like pondering as we kind of go forward. Sorry, Sylvie's question.
Yeah, questions from Sylvie is, with the home floor system, how could you replace the foundation from concrete base to another insulated floor foundation system?
Yeah, look, you could easily be using a timber subfloor. We chose not to, because the thermal mass of concrete is invaluable in terms of the energy performance, particularly if you focus on doing a solar passive home. So the jury is out on that, I suppose, if you were going to compare, you know, wrapping an airtight passive house home, and if you could use it with, if you could replace that with timber, although you do still get benefits even in passive house in the same way, because that's based on solar passive. It's a tricky one. What we did instead, or what we did theoretically, what we proposed was to use extremely low carbon concrete, which is out there. There's EcoPact is one maker of cement, and so yeah, we got our carbon footprint of the concrete down very low. So I'm not sure. If you're working with the energy rater, they will tell you when you do a design like this that getting thermal mass in is very valuable, because it helps that slow release when it heats up. It helps maintain the internal temperature both in summer for cool and for heat in winter.
So from your experience in this design competition, Lachie, do you think the life cycle analysis, the LCA, will be easy for people in the industry to pick up?
That depends. Look, Melanie did more of that than I did. She did more of that technical componentry. It's what she had to do was work with spreadsheets that had been pieced together by Jeremy Spencer, and now there are some other tools occurring. I can put them in the chat. Like, one of the best places to go to is the EPIC database. So in terms of understanding, I think it's Melbourne University have created that database, and it will list for you lots of information about basically the ratings of the carbon ratings of different products and materials.
So I have another question, Lachie, just on the seasons. With the house design that you've done, and given that solar panels don't work so well in the middle of winter, have you found that the majority of your energy use is in winter compared to summer, given that you've got the solar panels?
So talking from personal experience, so I couldn't tell you in terms of that house what that was slated. I mean, we did two studies. We did one in Sydney and one in Adelaide. Obviously, it's more mild in Sydney, and fluctuates more in terms of hot and cold in Adelaide. Look, the short answer is there are certainly days where in winter where you are not going to be able to supplement your heating load via solar power. So we know that's this continual story in terms of, that's the argument that people put forward to maintaining coal-fired power stations, for example, is, well, because we need baseload power. So we do need baseload power. And that's where going back to your question about batteries, definitely if we had batteries, that's another opportunity for us to store that battery, or if the electricity is stored in the car, and then we can send that from the battery in the car back to the house, certainly then we've closed that loop. But yeah, there are days when we definitely do not get enough sun in.
Yeah, right.
But in summertime, I guess I should answer that by saying in summertime, definitely our load would be covered in terms of the amount of sun we're bringing in to cover air conditioning. We'd still be exporting back to the grid, even on a 6.6
Yes.
kilowatt.
Yeah. And I think, do we have a comment there from Jason?
Yeah. Jason is just saying, please be mindful when using EPIC, especially when using EPDs, as they are not compatible.
Okay. Yeah. Yeah, look, it's a really fastly evolving space, and I'm not the expert on it. And but yeah, I think, like I said, I reckon there's an opportunity for quantity surveyors to step up and to take ownership in this space, to understand carbon accounting, because there is a need for it, a desire for it. One thing I just want to say that I think is incredibly important, my key takeaway from having undertaken this study is that we need to be doing this now. So you can see from undertaking a process like that, even a very efficient 10-star or 9-star home that has this embodied carbon attached to it, which is a relatively small four-bedroom house and an efficient house, that is going to take 17 to 18 years to pay back, So we can't afford to be doing anything other than that if we're going to get to net zero by 2040, 2050. Like, we've got to be doing this now.
Yeah, definitely.
And perhaps just a comment also on that is that, SA Power Networks or the grid providers don't want so much energy put back into the grid on the very hot days. So that is also lost, essentially, that
true.
power.
That's true. Yeah.
Yeah. So that would take, then if you didn't include that, that would take even longer.
Yeah, absolutely. And that's unfortunate. I mean, I guess that is one of the reasons why we are being paid so little for energy, is to encourage us to store it, for that very reason. Yeah.
Got another question here from Sylvie. What was the build cost for the design? Did you get to
That's
that
a really
stage,
good question. I think that there's another version of this competition that should be run to understand build costs to the same degree at which we understood the carbon load. I have tried to get that happening within the BDAA actually, as an alternative member organisation that I'm a member of as well. Yeah, it's we had to work within a $700,000 budget, and we did do some estimates based on that, which I could show you what our theoretical estimates were. The short answer is a budget of 700,000.
Was it like quantity surveyed, or was it kind
No,
of like estimated per square meter?
No, it wasn't. It was just working on per square meter. So I know we have a builder online with us, and maybe he can chime in, he or she can chime in at Watermains and say if this is completely off the mark. But so look, we created this theoretical table to make sure we got within the 700,000. I'm not sure if this was the final, but look, we worked to a primary build cost of 3,200 per square meter for the house. You know, some square meter rates that may be a little bit low, probably, you know, the carport might be a bit low, but you know, there was a little bit of money left over in there as well. You know, and we even include within that the design and documentation for all consultants. I think it sort of looks somewhat realistic. Does anyone want to comment on that?
Oh, I was just going to say, just from a quick look, that's kind of looks like it's on the right track. I also understand that you guys did that last year, where there was a little bit more material cost pressures, and still going through a lot of the supply chain bits that have been eased a bit now. Doesn't mean things are cheaper. It just means there's a little bit less risk on availability. But
yeah. So I mean, and costs, it's a question of how long is a piece of string. Obviously we've defined the piece of string, but you know, the specifics, getting down to the specifics of bathroom fixtures and joinery and kitchens and all that sort of stuff, where things can really add up, that's probably where you're going to get a lot of variation. I wouldn't be surprised if a house like that, including all the lovely landscaping that's around there, you know, you might even add 50 grand on top of that, because we did have some fairly extensive shade structures and so on. I'm also not sure that the Tindo solar system would cost 18,000, but I know that you could do a very decent solar system for 18,000, but I think Tindo might be a bit higher than that. So we just suggested Tindo because they're a local Australian manufacturer.
Yeah. Sylvie has made a very pertinent comment, of course, which is that if we wish the wider public to be able to afford this type of home, the cost of build naturally is the issue, you know, as it gets.
Yeah, we're in such a trap with that one, in terms of where I feel like I don't know that we're ever going to be able to bring that back in a way other than just you know, taking a home and multiplying it, you know, to get efficiencies. So you know, whilst some of the builders in the market are ones that we believe we'd prefer to be without, because their model is unsustainable in terms of the way they were working off low percentages and pumping out high volume. You know, it's a volume issue, and and
you need the champions, you know, to take it up initially.
I think we do need the champions. We also need a little bit more standardization, and I think, like anything, if we're coming from government to motivate people to understand where the big dollars are and how to drive efficiencies and get everyone speaking the same language, we could absolutely do it. But there's just so many inefficiencies in our industry at the moment, so much wasted material. You know, is prefab going to answer that question? Maybe not right now, because a lot of people doing prefab just charging a premium because they can. But it's also still expensive to transport buildings, you know, halfway around Australia. So it's a complex one.
Yeah, and Sylvie just obviously writes there that yes, you agree on the standardization. Yeah. So that was fabulous. Thanks so much, Lachie.
Learned a lot today. That was really good.
Yeah.
Yeah,
All right.
thank you so much for your time, everybody.
And thanks everybody for coming. Yep. For another sustainability. We'll see you next time.